All right, so it says consider the graph below. Determine the sequences of transformation that could be applied to the parent function f of x equals x to obtain the graph below. So what they're saying is f of x equals x, the diagonal. Let me change the color on that. So f of x is this graph right here. F of x equals x has a slope of 1 and it goes through the origin. So you're going to go up 1 over 1. That's why we call it the diagonal, because it just goes across the xy plane and it like it's a diagonal line. And you're basically just drawing a diagonal through each square. Okay, so this is f of x equals x. All right. So now what did we do to that red line to make it look like the blue line? Well, the first thing we did is we could say we reflected. There's a couple of ways you could do it. One was you could say we reflected that over the x-axis. And you guys should remember this from when we did this in our geometry class, the reflections. We reflected over the x-axis, and then we did a vertical stretch of 2, and then we shifted up 6 units. And I'll explain what that means in a second. And this is one scenario. So when we flip this over the vertical axis, we get like a little graph that looks like this. Okay? So that changes the slope of it. In other words, we took the negative of f of x, right? So that's the first thing. And then the slope is different too. If I look at the slope of the diagonal, my slope on this line is -2. In other words, if I go down 2 over 1, the slope of the blue line, let me start labeling the things on the blue line. The blue line is the equation y equals -2x plus 6. Okay? So what we're looking at is what do we do to f of x to get something that looks like this? Well, one of the things that I know is that the vertical stretch changes the slope. So this had a slope of 1. So the vertical stretch would be multiply that by 2. So to get my g of x, to flip it over the x-axis, I had to take the negative of f of x. But to change the slope of it, I had to multiply by 2. And then to make, because up here, my y-intercept is plus 0, right? I had to shift it up, so I had to add 6. So this is what it looks like. This is the verbiage for it, right? I reflected over the x-axis. That's this negative sign. I vertically stretched it 2. That's where the 2 comes from. And then I shifted up 6 units. Does that make sense? Okay. Now, there's another way you could do that too. You could say that there's 3 scenarios actually. You could say that I shifted left 3 units, reflected over y, and vertically stretched by a factor of 2. And then the last scenario is that I reflected over